Hello, my name is Claudia Valero. I'm currently taking Physics 1101 at Georgia Tech, and this is my public lecture review. So, I attended two public lectures over the course of the semester. The first one was the physics of superheroes, and then the second one, which is the one that I'm going to be talking about, is bold ideas in physics, which was done by Professor Ashtekar. Now, I really enjoyed it because we talked about Einstein and the Big Bang. And to me, the Big Bang was something that was sort of a finalized theory. I thought that, yeah, the Big Bang, we've got it all figured out. But I was very wrong. Now, Professor Ashtekar, I'll go now to what happened in the lecture. He first started talking about what a genius Einstein is, because he was truly ahead of his time and he was just one level, 2, 3 above everyone else at the moment. And what he wanted to do was that he wanted to create an equation that could describe almost anything. And he came pretty close to it with relativistic motion and EMC squared, right? And I thought it was kind of funny, the anecdote that he said. He said that when he created this, everyone was telling him, no, you can't do it. That's not going to happen. And then he wrote everything down and he sent it to his other famous physicists of the time. And he said, I'm not even going to defend it because you're going to read it and you're going to think, yeah, this is totally right. It was self-explanatory to him. And it turns out that it was, because everyone agreed that it just kept working, and it still keeps working. Except for one thing. How does this explain the shape of our universe? So, our observation of the universe is that it is expanding at the moment. How does that go in line with what Einstein said? Now, there were two solutions to this problem. The first one didn't work, and it sort of looked like this: two cups into another, kind of compressed a little bit, and then kept going. But there were other problems, and that one doesn't really work out. The second one is more in line with the Big Bang. And what it talks about is that right now, this is our universe, and if you turn back time, you compress and compress and compress. Imagine there's a hole in here, and it just keeps compressing and compressing and compressing, and it forms a sort of funnel. And this is where the Big Bang comes from. Now, the Big Bang comes from that there was one time something so compressed and so small that it just exploded and created our universe, and since then it's been expanding. And that goes with everything that we've observed, which is just that it's expanding, right? But there's problems, because what happens when you compress it so much? So we think of it as a point. Now, Einstein himself said that if we were going to use this to describe the universe, maybe the definition of a mathematical point, we shouldn't limit ourselves to it, because all the equations fall apart. There's no mass, there's no nothing. So how can we describe it? And how do we work around this problem? So maybe it's not a point. Then what is it? They said, well, maybe it's a really compressed volume that's really dense, and that's what exploded and made the Big Bang. And now that brings us to, how did that volume form? So what it talks about is that this is our universe. Where does this volume come from, this very small volume? So let's just add another universe to it that came before it and was compressing. So we do this, there's a universe that compresses and compresses and compresses. It forms a very small volume, then it explodes into a new one. Now, of course, this is not a perfect model again. It should keep funneling in and make something small and then bounce into the other one. And that's what this is called. It's called the Big Bounce, and it's a transition from the Big Bang theory. Now, that is what we talked about, and it was impressive to me because Again, I thought that the Big Bang Theory was a finalized theory. Yep, that's what we got. But it turns out that no, physics is something that is constantly evolving. It's looking to know more, and this is one of those parts where I'm just aghast of what we've learned. However, like any theory, this one still has its problems. We might ask questions, right? What is going to happen to our universe? Is it going to expand and then stop expanding and then compress again and form another universe? What was the beginning of this? Is it just the same universe expanding and contracting infinitely? And to what is the limit of expansions? What is the limit of compressions? So we still have a lot to learn. And my major takeaway is I'm just really excited to hear new theories about it because I now know that everything is not set in stone. Thank you very much.